All right, now I want to show you an example of how to specify auto layout constraints and explain the intuition behind it. So I'm going to use the same example that we were using in class on Wednesday. And we've got the green view here, and let's add a red view to it. And let's first talk about the distance to the left. So it should have a margin of 50 points to the left side of the green view. And if we wanted to phrase this in terms of the auto layout attributes that we saw on the slide before, the intuition would be that the leading edge of the red view has a 50-point distance to the leading edge of the green view. If we wanted to somehow codify this or actually encode this, we could write it like this in pseudocode. So pseudocode is code that won't run, it won't compile because it doesn't actually adhere to the actual rules. But at the same time, it is code that expresses our intention. So it would look somewhat like this, right? The red view has a leading edge and the green view has a leading edge. And if the leading edge of the green view would be 0, then the equation on the right would equal to 50. So the leading edge of the red view would be 50, and that would be the x value for the red view. So that's the intuition behind this auto layout constraint that we're going to add. And let's now take a look at the actual code. And the actual code looks somewhat frightening at the first sight, but it's actually very, very logical. So please bear with me while I explain it. So first thing, we are creating an auto layout constraint. So we are using the initializer of the corresponding class, which is called NSLayout constraint. When we want to use the initializer, we just open a parentheses and then we're passing a number of arguments depending on how many arguments this initializer takes. And in this case, actually, we have to provide 7 arguments. So that's quite a lot, but they actually make a lot of sense. So let's take a look at the first 2. The first 2 arguments are the first view that we want to use for the relationship. So the whole goal of this auto layout constraint is to create a relationship between 2 views, and the first 2 are going to represent the item and the attribute. So we say that the first view is the red view, and then it should be the leading edge that we want to relate to some other attribute of some other view. Then we can specify how we want to relate this. So in the pseudocode, this relates to the equal sign. We only have 3 options for this parameter, by the way. So here we are using equal. We could also use greater than or equal, or less than or equal. So we only have these 3 options, but for today we're only caring about the equal, so you don't have to worry about the other 2 for now. Then what follows is already the second view and the second attribute. So we want to relate the leading edge of the red view to the leading edge of the green view. So that's what we can express here. And finally, we have to say how we want to relate them. So what are the values with which we want to relate them? And this is going to be a distance of plus 50. So the multiplier actually can be used for a multiplication. So if we wanted to say that it should be twice as wide or 5 times as wide or maybe half as wide, these requirements could be expressed by setting a multiplier. But here we actually have a hard-coded distance. So we're just using the constant and we are adding 50 to this relation. So that's the first auto layout constraint that we create for the margin. Let's take a look at the second one and let's choose the width for this one. So we know that the width of the whole green view is 300 points, and the width of the red view now is supposed to be half as wide as the green view. So we can again express this requirement in natural language to build an intuition. So the width of the red view is half as long as the width of the green view. This expresses this requirement. And in pseudocode, again, it would look somewhat like this. The width of the red view should be the width of the green view times 0.5. So we're taking half the width of the green view to compute the width of the red view. And again, the actual code takes exactly the same arguments as in the previous example, but now we have to relate the width of the 2 views with another, and we have to express it in terms of a multiplication. So that would look like this, that the first 2 items, again, or the first item again is the red view, but rather than using the leading attribute, this time we're going to use the width attribute. For the relationship, we're going to use equal as before. And then we want to relate the width of the red view to the width of the green view, so that's the second item. And then, as I said before, this time we're using the multiplier because we're expressing the requirements in terms of a multiplication rather than in terms of an addition or a subtraction. So here we are multiplying the width of the green view with 0.5 and assigning the result of this to the red view, to the width of the red view. All right, and note that with only these two constraints at the moment, the example is incomplete. We didn't provide enough information for AutoLayout to actually compute the full frame, right? So at the moment, it can only compute the X value and the width, but it cannot know where the red view should be positioned on the Y-axis, and it also can't know how high it should be. So we would have to provide this information because otherwise AutoLayout can't know where to place the red view and how high it should be. And in fact, if you already used Interface Builder, now we would get this information exactly in Interface Builder if we were using AutoLayout there, and we only set these two constraints. We would get the red lines, and AutoLayout would try to tell us that we still need to set a Y value and a height value for the frame of the red view.